All right, so in this chapter, we've been talking about cladograms and how to read them and how to make them. And so this worksheet had some practice problems, and I wanted to make sure that I gave you some explanations in case you were absent. So the first one, we see a cladogram there, and it asks which traits are shared by birds and crocodiles. So the first thing you're going to do is you're going to find the point at which birds and crocodiles diverge from each other. So here's crocodiles, here's birds, and they diverge here, which would mean that any of these traits would only be unique to the birds. But any of the traits past this point backwards to the beginning, we're assuming we're starting here, so amniotic egg, keratinized skin, and parental care, these would be traits that would be shared by both the crocodiles and the birds, and then at this point they diverge. Crocodiles do not have any of the other traits past this point, but then the birds would have these additional traits. So it would be parental care. I'm just going to write parental just so we can get through this a little faster. So parental care, I'm just going to put skin, the keratinized skin, and then the amniotic egg. These would be the traits that would be shared by both the birds and the crocodiles. Next, which traits are unique to mammals? So again, I'm going to change my color here. So if we take a look at the mammals, remember this tracks back to the beginning would be back here. The common ancestor to everybody would be somewhere back here that we're not seeing. And so we notice that this branch, so amniotic egg, everybody has. And then we branch this way and this way. So these three traits, which are only on the mammal branch, so this would be hair, mammary glands, I'm just going to write mammary, and endothermy, meaning being warm-blooded. These would be traits that are unique only to the mammals. All right, our next question, which organisms have keratinized skin? So now we're going to find the trait of keratinized skin. Here is keratinized skin. Sorry. And then if we look at keratinized skin, everything after this point would have it. So because it's prior to this split. So that would mean, I'm not going to fill in the blank here, it would be the snakes, turtles, lizards, crocodiles, dinosaurs, and birds. Pretty much everything after this point. I'm just going to, in fact, put an arrow. What is the most recent trait shared by dinosaurs and birds? That would be bipedalism. Here's our dinosaurs and birds and where they branch, and the most recent trait prior to them branching would be bipedalism. All right, are turtles more closely related to crocodiles or to mammals? So what you want to do here is we're going to just change my color here. So crocodiles, let's see, turtles and then crocodiles. So turtles and crocodiles, if we look at where they branch here, right? Which means they share the egg and the skin. But turtles and mammals, if we look here, they branch further back and they only share the egg. So they share less characteristics and they branch further back. So the turtles would be more closely related to the crocodiles than the mammals. Are dinosaurs more closely related to birds or crocodiles? So if we look at the dinosaurs, we have birds and crocodiles. Now this one throws people off because they're like, oh, but they're equidistant. True, but the dinosaurs and the birds share an extra characteristic. The dinosaurs and the birds share bipedalism. The dinosaurs and the crocodiles only share parental care. So because this branches further up and they share an additional characteristic, the dinosaurs would be more closely related to the birds. So be very careful about that. Okay, so do crocodiles, number 7, share a more recent ancestor with dinosaurs or with birds? Now this one's a little bit tricky. So if we take a look, here's our crocodiles, and here's dinosaurs and birds. So some people would be like, oh, but dinosaurs is next to them, so the answer is dinosaurs. The answer is actually that it's equally related, that it's the same. Because if we look at the point where they shared a common ancestor, it's here. It doesn't matter that the dinosaurs, that the birds are showing, like branching further up and that they're kind of further away. The dinosaurs and the birds are technically equally related as far as a common ancestor. In fact, sometimes these two could even be flip-flopped with each other. You could have had birds go this way with the two characteristics and had dinosaurs go this way because they don't actually even have an additional characteristic. So you could actually flip-flop. This is called a node, and you could flip-flop that node. So this would actually be an equal relationship because the common ancestor is in the same spot for both the dinosaurs and the birds. All right, do dinosaurs and birds form a clade? Your answer would be yes. because a clade is an ancestor and everything after it. So our node, our ancestor would be here, and then dinosaurs and birds would both come from that node. So that would be a clade. If I show it to you here, it's getting a little messy. Whoops. So yes, dinosaurs and birds would form, this would be, a yes. And then do crocodiles and birds form a clade? The answer would be no, because crocodiles and birds share a common ancestor, but the definition of a clade is that it's the ancestor and then all the organisms that came from it. So dinosaurs would also be included here. So crocodiles, birds, and dinosaurs would form a clade. It would be 1 point and then every living thing after that point. But you can't ignore the dinosaurs and just say that crocodiles and birds are clades. So think of it as a branch. If I cut my branch here, it would be the ancestor, or here, everything, everything after, or here, actually, then everything after this point. If I cut it here, it's everything after this point. If I cut it here, everything after this point. So that's how you would read whether something was a clade or not. Okay, so in other recordings, I covered the other questions, but I didn't cover this very last one in another recording. So this is how you would read it from an amino acid sequence, and this is a common one on the AP exam. This may also be free response on your test, one like this. I have, to be honest with you, my free responses include some like this, some like this one here, even there's, I believe, some like this one. So you could be given the data in multiple ways, and you need to know how to make trees from all these. Now, this is from an old AP exam, and they actually helped you out a little bit, because you'll notice they already have the human here. So we're looking at amino acid relationships. The most related to one another are going to have the most similar amino acids. That's the whole concept, that DNA mutates over time, and amino acids would then possibly be changed by a change in the DNA. Remember how the 3-letter codes in RNA, etc. So they already put the human here. So let's take a look. So here's the human. Let's see who's the closest to the human. So when I look, I notice immediately that the gorilla only has one difference from the human. But then I see the chimpanzee, and they're actually identical to the human. So that would mean that the chimp needs to be the closest relative. So that's it. Now, one way to go about this next is to go, well, who seems to be the most closely related after that? Well, if we look at this, I notice that the gorilla only has one difference. The horse actually has 2 differences. And the zebrafish has actually another difference even from the horse. So it even has more differences. In fact, if I look at the zebra, he has 3 differences from the human and the chimp. So the one with the most differences, which appears to be the zebra, that's going to be our outgroup, so we would put them here. Remember, this is showing that they are the most different, that they shared an ancestor the furthest back. So in the relationship scheme, they're the least related. We said that the gorilla only had one difference, so it makes sense for the gorilla to go here. The horse had 2 differences, so we're going to put the horse here. So this would be our tree. Now, which 2 organisms' positions could be swapped? That would be the human and the chimp. Because remember, this node can actually pivot. This could be flip-flopped. Human and chimp, it's just kind of random that we put them that way. It's not purposeful that, oh, the chimp came before the human. We don't know that from the way this is drawn. This is basically showing these 2 could be flip-flopped. What's the outgroup? That would be the zebra. They have the least in common with everybody else. And then circle the position of the closest ancestor to the human and the chimp. So these are ancestors. These nodes are the ancestors. So the closest ancestor specifically to the human and the chimp would be, would be right here. This was our chimp. And it would be right here. This would be an ancestor, the last time we shared a common ancestor. And then that diverged into the human and the chimp. Further back, this would have been the ancestor that diverged into the gorilla and some other organism, which then continued and then split into the human and the chimp. So that's how you're going to read one of these. Also be aware it doesn't have to be that the closest ones are at the bottom. It could be drawn this way with the closest, so it could look like this, and then these would be this would be your outgroup down here, and these would be your closest up here. So that's another possibility. I've also seen it this way. Where they come down like this, in which case like your outgroup is back here, and then your closest relatives would be here and here. A lot of times, most of the time in recent AP exams, what I have seen, and this is very helpful, I think in the last maybe 10 years, every question I've seen on a free response, they've given you a framework of some kind. They haven't always provided some of the info for the framework, but they've given a framework. So that's very helpful, because if you can already see like something like this, you can already tell, oh, okay, so there's going to be two things that are very related and two other things that are very related. So that helps a lot compared to the ones that I've shown you earlier where you have to draw the cladogram from scratch.